Guys, welcome to the next part of Mosfet lecture series. I hope you all understood whatever the thing that I have delivered in the last class. If you are really understanding all the content, whatever that I am delivering here, don't forget to click that like button and kindly share it with all your friends. Okay, so let us continue. In the last session, we have been observed one different question and we also saw how to calculate the value of drain current in terms of IDSS and pinch off voltage VP. In the same fashion, suppose in the same question, if you are requested to calculate the value of transconductance GM, then how do you calculate that? What is the formula to calculate the value of transconductance when drain to source saturation current is given and pinch off voltage is given? So just to note it down, the formula is minus 2 times of IDSS upon pinch off voltage VP in bracket 1 minus VGS upon VP. So by using this formula directly you can calculate the value of transconductance. See, this transconductance is known as, that is nothing but the ratio between the variation in the value of drain current with respect to gate to source voltage. That is called transconductance. It can be directly written as, in saturation region, it can be actually written as 2 times of K into VGS minus VT. That is the actual formula. But the value of threshold voltage is not given in our question. So it is not, under the value of K also not given. K means mu n Cox omega by L. We know that already. So when both are not given, how can we proceed further? So the thing is, this is the actual ways. If the value of thermal voltage is given and K everything is given, then directly by using this formula you can explore the value of transconductance GM in saturation region. Suppose if it is not given, sir, given it is pinch off voltage under drain to source saturation current, in that case you can use this formula. Now for me, I am giving a small request, take this all data. For this question, can you please explore the value of transconductance? Because IDSS is known, VP is known, VGS is known. Just to substitute all the values, drop your answer in the comment section. Let us go to the next question. Here the question is given M1, M2 MOSFETs, right? They have given, so they are called N channel MOSFET. I forgot to write that. They told that M1, M2 N channel MOSFETs are identical, that is NMOS only, identical to each other. They told that they have taken two identical devices without having any difference. It means what? In MOSFET, whenever they are giving this clue, two transistors are identical to each other, then the current consumed by them are also going to be identical. I can directly write current consumed by the MOSFET 1 and current consumed by the MOSFET 2 are going to be same. Why? Because they told they both are identical to each other. Okay sir, fine. So then what is the conclusion? M1, M2 are identical to each other, and also assume that MOSFET M2 in saturation region. Where is MOSFET M2? See, this is MOSFET M2. If you observe MOSFET M1, already gate terminal and drain terminal are shorted together. Do you remember? When I was solving the problems in our previous lectures, I told you whenever drain and gate are shorted, directly you can say that MOSFET is in saturation region. So first MOSFET already in saturation region. Now what they concluded is second MOSFET also in saturation region only. So both are operated in the same region, and already they told that both are identical to each other. And you also know gate current will always be 0 ampere. There will be no any current through the gated terminal. So this will always be 0 ampere. Under this situation, what will happen? Whatever the current that is going through the first transistor, that is, we can simply call this current is drain to source current of the MOSFET 1. Yes sir. Then according to the given data, we can simply write the value of ID2, or see there, current through the second MOSFET we can call ID2. Actually we are requested to calculate the value of IX. IX means current through the second MOSFET is dash. So that is ID2 I have written here. It can also be written as IX according to your given question. But what we understood that when both MOSFETs are identical to each other and they are connected to together, actually what's happening here is the circuit is simply called current mirror circuit, and the second circuit will be driven by the first circuit, and the first circuit push the second circuit to work as a constant current source. So that could be done in this way. So they have connected two MOSFETs, they are identical to each other, they have connected them according to the configuration shown in below. When both are identical to each other, automatically what will happen? Whatever the current, see, identical means internal specifications, their entire parameters are similar to each other. That is called same each other. So in that case, we can directly take that the value of ID2 equal to Ix equal to ID1, whereas the value of ID1 is equal to 10 milliampere. So the correct answer for this question is, since both MOSFETs are identical to each other, so the current consumed by them are also going to be equal. That's also, you can directly write your answer. Okay sir, suppose at sometimes what they will give is, it's a rare case, but you can observe the question in that format also. You can observe same type of circuits will be given in your examination, and they will be giving you the data like this. The value of omega by L 1 is equal to, they will be giving you some value. Let me call some, what I can say, we will take some parameter x1. Similarly, they will be giving you the value of W by L2, some other parameter x2, and they will be giving you the value of drain to source current of the first transistor. They will be giving you some value. Okay sir, ID1 will be given. ID1 given. Under this situation, you will be requested to calculate the value of ID2. How will you calculate this? Since both MOSFETs are identical to each other, in that case, so they are going to be consume the same current in the first case. But here again MOSFETs are identical to each other. The only thing is the value of W by, that is width to length ratio, is differ from each other. In that case, what can we do? We know the formula basically. MOSFET ID1, I am writing the general expression, not 1 at all. ID can be simply written as, how will you write down the expression for ID? So when MOSFET is being operated in the saturation region, then it can be written as mu n C ox omega by L. Of course, there is a 2, I am keeping it here. And then we can write VGS minus VT whole power 2. That is the drain to source saturation region current, drain current. Since they told that the changes is only with the W by L, other parameters are constant. It means I can write like this: ID2 by ID1 equal to, in ID2 the only parameter which is varying is W by L ratio. Similarly, in ID1 also the only parameter which is varying is W by L ratio. So when they are giving different value for this, by substituting that those two values, you can directly write down the answer for ID2. Okay, I hope you all got the conclusion. As I told you that problem by problem I will be covering all the concepts which are required to completely solve all the questions. So don't be bothered, just to keep a note with you. Even note also not required, because we are going to repeatedly solve so many questions. After sometimes everything will be stored in your mind. And I'm also not going to derive so many equations. Almost already I have given 98% of the N MOSFET, everything. So if I will find anything new, if I will miss anything, I will be covering in the upcoming lectures. So this is all for this lecture. Remaining things we will see in the next class. Thank you all.